And projectiles, part B. A particle is projected up an inclined plane with initial speed 80 meters per second. The line of projection makes an angle of 30 with the inclined plane, and the plane is inclined at an angle theta to the horizontal. The particle strikes the plane with an angle of the inverse tan 2/3. And there was no diagram given this year. So we're told the angle is theta to the horizontal, 30 with the incline, and the initial speed is 80. And it lands, we're given the landing angle. So the landing angle, we call it beta, is, and they give us this information here. So if we look at our initial velocity vector, we are going to have 80 cos 30 times I plus 80 sine 30 times j. Cos 30 is root 3 over 2, so 80 divided by 2 is 40, so 40 root 3i, and the sine of 30 is a half, so we're going to get plus 40j. We're up the incline, so we have accelerations involved here for both. So for my j, we've rotated our I and j around to be like this. We are looking at theta. So minus g, it's adjacent, minus g cos theta. And in that y direction, we're going to have minus g opposite theta sine theta. Like all of these questions, if we work out the time it takes to get here, we can say the displacement in the j direction is equal to 0. So my ut plus a half at squared is equal to 0. My u, my a in the j direction, so 40t minus g cos theta over 2 by t squared is equal to 0. Factor out my t to get 40 minus g cos theta over 2 times t equals 0. So my initial time of 0 being here, and 40 would have to be equal to g cos theta times t over 2 for the bracket to be equal to 0. So 80, and we're going to divide by g cos theta, would have to be the time it takes to get to where we said already, this landing point. We're given the information about the landing angle, and we know that at the landing angle, we've called it beta. Tan of beta is equal to minus the velocity of, well, we've called it j, I'll keep it at j, minus the velocity of j over the velocity of I. So I get the two velocities at this time. I should be able to fill my answer in here, and it's going to be equal to 2 over root 3. So let's have a look at both velocities. I'll do them here. So the velocity of j is equal to u plus at. What do we get for u? Well, we have it over on the left there. You can see it's 40. 40. The acceleration, just double check it. This one, minus g cos theta. And the time, 80 over g cos theta. My g cos theta is cancelled, so the velocity of j at this point is 40 minus 80 minus 40. Velocity in the I direction is also u plus at. What do we have for u? 40 root 3 up here. So 40 root 3 minus g sine theta. You can see that here. Minus g sine theta times time, which is 80 over g cos theta. So you can see we're going to have a tan in here. The g's cancel. Sine over cos is tan, so we're going to be left with 40 root 3 minus 80 tan theta. So we fill those two bits of information in here. We are going to get minus the velocity of this guy, so that's going to be 40 on top. We're going to have 40 root 3 minus 80 tan theta on the bottom. 40 root 3 minus 80 tan theta. And that's going to also all be equal to 2 over root 3. So 40 by root 3, this one by this one, is equal to twice the bottom, which is 80 root 3 minus 160 tan theta. So we should be able to get the landing angle here. Is that what we asked for in part 1? The particle strikes the plane. I didn't write down the question. Great. Mathematician not writing the question. Let's see what the question asks. The value of theta. And then we'll write part 2 in a minute. So the value of theta is going to be, well, if I bring the minus 160 to the left to make it positive, I'm going to get 160 tan theta is equal to 80 root 3 minus 40 root 3. So it's going to be 40 root 3. So if I divide by 160, I'm going to get tan theta. 40 over 160 is 1 over 4. I'm going to get root 3 over 4. And the inverse of that guy on a calculator will give me theta to be 23.4 degrees. Now we're at the second part of the question. The speed with which the particle strikes the plane. So we know this is the square root of the velocity of I to be squared plus the velocity of j to be squared. We just have a tiny bit of work to do just to get the velocity of I. We have the velocity of j is 40 or minus 40, but we're going to square it. So we're going to get the square root of this one, the j, 40 squared. And tan of theta being root 3 over 4. Well, what's 80 tan theta? 80 by root 3 over 4 is going to give me 20 root 3. So we're going to have 40 root 3 minus 20 root 3. So it's going to be 20 root 3 squared. So that's going to give me 400 by 3, which is 1200. And 40 squared is 1600. So the square root of 2800. So I haven't learned that one off. I need to use my calculator. 52.92 without the square root meters per second.